Okay, we're going to do another problem. This is 6.73 from the Neaman Microelectronics text. And this tells us to find the voltage gain from the input to VO1 and from VO1 to VO2, and then to find the overall small signal voltage gain. Now, in this particular case, our input is on the base of Q1 and our output is on the source of Q1. This makes that a common collector amplifier. And for the second stage, the input is on the source and the output is on the collector, making this a common base amplifier. So we can quickly write our gain formula down. AV1 is the gain from VI to VO1. This is equal to GM1 times the total resistance seen in the source divided by 1 plus GM1 times the total resistance, seen in the emitter, not the source. Now, it gives us the currents flowing through the transistors at 1 milliamp. So GM1 is equal to GM2 is equal to IC over VT, or 40 millisiemens for this particular transistor. So plugging in some numbers, we can find the voltage gain of that first stage. All right, so when we plug in our numbers, we come up with something like 0.49 volts per volt. Now I should note that 1 over GM2 is approximately 25 ohms, and this is in parallel with 1 kilo ohm. So if you just made the approximation that that total resistance was approximately equal to 1 over GM2, that would have been acceptable. All right, going to the second stage. This is a common base amplifier. So for our common base amplifier, we know that the gain is GM2 times the total resistance seen in the drain, in the collector. Now we note that looking back into the transistor, we would normally see R sub 0, but in this case, they've told us that the early voltages are equal to infinity, which means that the transistor's output resistance R sub 0 is equal to infinity. So it won't show up in the gain formula. So here we have 40 millisiemens times 4 kilo ohms is equal to 160 volts per volt. Now, the total voltage gain, AVT, is equal to AV1 times AV2. In other words, we have this at about 79 volts per volt for the total gain. All right, so that's it for this video. Now, if we were to further ask you what the input resistance was, we could do that. So the resistance looking in to the base of Q1, Ri is equal to R pi 1 plus beta plus 1 times Re in parallel with 1 over GM2. The output resistance in this case is just equal to RC, because the resistance from the transistor is infinite. So we'll stop there for this exercise.